All right, check this out. We're going to talk about the scariest topic in C++. That topic, pointers. All right, let's get into this. Let's open a folder. Let's call this, make a new one, call it pointers. Shocker. All right, we need main.cpp. We're going to use the console, so we need IOStream. We need our int main. If all went well, we're going to return 0. All right. So what on earth is a pointer? A pointer is a number that represents the address of a variable. So let me say that again. What is a pointer? The pointer is just a memory address. That's it. It's a variable, we'll give it a name, but it stores the memory address of another variable in our program. Okay, so our program uses memory. Our computer is full of it. You guys have gigabytes of memory. Now, every single byte of memory on your computer has an address. That's how we access them. So memory and the use of it and the understanding of how it works is probably the single most important thing you can learn as you learn how to program. Okay, it is mission critical. So let's get into this. So to get memory address, let's make a variable, and when our program is compiled, our compiled program is going to assign an address to every variable we create. So let's make one. Int a, let's give it the value of 5. Okay. So if I wanted to get the address of a, how would we do that? So this is where pointers come in. So a pointer is created just like this. We'll go int, and we're going to use the star symbol, okay, to represent a pointer. We're going to give it a name. So ptr, we'll call it a. Okay, now again, what's a pointer? The pointer is a memory address. So how do we get the memory address of something? So we're going to, in this case, we're going to get the memory address of a. So equals, now to get the address of it, we're going to use the ampersand symbol, a, just like that. That's it. So it looks a little weird. We've got like multiplication symbols in here and ampersands and what's going on. So let's read this backwards, because this is kind of how your compiler is going to deal with it. So we've created a variable, an integer called a, and we've assigned it the value of 5. So if I read this backwards, 5 is assigned a, which is an integer. Now we take the address of a and assign it to a variable called pointer a, which is a pointer to an int. Okay, let me read that again. 5 is assigned to a variable called a, which is an integer. Okay, it holds 4 bytes or whatever an integer holds. Okay, now in this line, we get the address of a and we assign it to a variable called pointer a. Okay, again, whatever we call this is fine, just a variable name. We assign it to a variable called pointer a, which is a pointer to an int. Okay, play that back a couple times, make sure you understand what I just said. All right, so what is a pointer? A pointer is just a memory address. That's it. It's a number. Okay, now that number is represented in hexadecimal format, so it's going to look super weird when we print this out. But let's do that. So std cout. Let's print the let's say a equals. Let's do a. Okay, now let's do the same thing with our pointer. Whoops. Let's say ptr a equals. Make sense? Look at that real quick. Make sure this is making sense to you. All right, so 5 is equal to is assigned to A. The address of A is assigned to this pointer. Okay, now we're going to print A equals A, and then we're going to print pointer A is equal to this. So we're going to print all this stuff out. Let's see what happens. Let's compile this bad boy. So clang main feed at main.cpp dash let's call it app.exe, and let's run it app.exe. Hey, FYI, if you're on a Mac, okay, you need to do a ./app.exe. Just FYI. I don't know why Windows does it different. Boom. Look at this. A equals 5. Pointer A is, what the heck is this? That is a hexadecimal number representing the memory address of A. That's all it is. Okay? Now, great. What am I going to do with this? So you can do some really neat things with this. Now, we have the address of A. So if I wanted to see what was stored in this address, I have to do what's called dereferencing it. So I'm going to do that here. Let's just put it right here. std cout. I'm going to say the value stored in pointer A equals. Now, pointer A, that's our pointer. Let me just finish this. Gosh, can't type. Okay. Obviously, this is just the pointer. Now, if we wanted to see the value stored in it, we need to dereference it. Now, in the same sort of way, we put an ampersand in front of A to get its address. We can kind of do the opposite. We can put that little star symbol in front of our pointer and dereference it. Okay? So what this means is the value represented by this pointer. Okay? Hopefully I'm saying that correctly. So let's see what this is. So let me shrink this up so you guys can see it. I'm going to save it. Make sure you save. If you try to compile it with like a little white dot right here, it's just going to compile the last saved version. You know, it's not going to compile what's on your screen. So save it. Let's go ahead and clang this bad boy. I'm just recycling my old commands, so I have to type them. All right, look at this. A equals 5. Pointer A, here's the address of it, and the value stored in pointer A is 5. Hot dang. So now let's start playing with addresses. Let's, what do we want to do? Here, let's change the value of A without changing this A. Okay? So let's take our pointer, pointer A, okay? Remember, this is just an address. Let's dereference it and then assign it the value of 10. Cool? Okay, now notice I didn't say A equals 10. I assigned the value of 10 to this a dereferenced pointer here, okay? And then let's, how much do I want to copy? Pointer A, let's just copy this whole mess. Copy, let's put it right here. Okay, so again, we're just going to print out the value of A, the pointer, and the value stored in pointer A. Okay, so I'm just going to put a little changed the value of A. That way we can see where it happens. And cool. All right, let's go clang. Let's compile it. Boom. Let's run it. And sure enough, A equals 5 here. Here's the pointer address. Okay. The value stored in pointer was 5, so it matches. And now we change the value of A. So now A equals 10. Now notice, I didn't assign 10 into A. I went through the address of it. But you can see the address is still the same. Okay, and then again, I dereference this address and I get a equals 10. Super cool stuff. Again, you might be like, great, how am I going to use this? Well, it turns out, and we can't get into all of it right now, but I want to give you a little snapshot, a little picture of how this might be handy. To do that, I'm going to delete most of this stuff. So let's get rid of all this stuff. Let's do this. Let's create a little function up here. Let's say we'll make it a void function. It's not going to return anything. Let's say add 10. Add 10. We're just going to add 10 to my number. Okay. We'll say int a. We'll say int number. All right. And let's make our little function here. We'll say number equals number plus 10. Okay. So I'm going to feed a number into this add function. I'm going to add 10 to it and store it back to itself. Okay, makes sense? So let's use it right here. Let's go add 10, and then let's feed it a. Cool, makes sense? Let's shrink this up so we can see it. Okay, don't worry about our pointer right now. We're going to use it in a second. So what do you think is going to happen? Right now, we took 5, assigned it to the variable name a, which is an integer. Okay, and then down here, we fed that value a into our function called add 10. And add 10 is going to take our number, add 10 to it, and assign it back to itself. Okay, now, FYI, there's a problem here. But at first glance, it seems like we're going to take a and add 10 to it. So when we see out, std, see out a, we should get 15, right? Whoops, and line. Cool. Let's see what happens. Playing. Ruh-roh. I thought we were supposed to get 15, and we only got 5. What's going on here? This computer's doing exactly what we told it to do, turns out. We just didn't think about it right. So what's actually happening here is a, when we fed a into this add 10 function, we fed a copy of it, just a copy. We didn't actually give it a. We gave it a copy. So this copy, we took the copy, we added 10 to the copy, and then we assigned that new value, 15, to the copy, not to a. A is still down here. We didn't mess with it at all. So if we wanted a function that took a and added 10 to it, and it actually changed this value, how would we do that? So it turns out you need a pointer. Okay, we need to feed it the address of a, mess with that number using the address, and then we're done. So let's do that. So we just made a pointer right here. Okay, so we need to change our function here to need a pointer. So we know to give it a pointer, we put the little star symbol here. Okay, so now our number is a pointer. Okay, now in this case, it's a memory address. So I don't want to just add 10 to a memory address. Okay, because memory address is just a number. So I'm going to end up, taking this address, like take your home address and then skip 10 houses down. Like that's not what I want to do. So I want to change the value stored in this memory address. So what do? We need to change the value stored in a memory address. We dereference it. So do it like this. And now again, I get an error because I need to dereference this one too, because we're dealing with values. So again, 10 plus the value stored in number, and then we're going to assign that to the value stored in number. Let's save this. Now down here, I can't just give it a, it's expecting a pointer. Okay, so I need to give it the address. Okay, so I can do this one of two ways. I can just either give it the address, just like this, which will compile just fine, or I made a pointer right here, so we might as well use it. Both are the exact same thing. Pointer a. Okay, cool. So now, again, notice I didn't mess with a. I assigned 5 to a here. I got its address, and then I fed the address into this add 10 function, and then I'm going to see out a. I didn't add anything in here. Okay, so let's see what happens. Let's CLS. Let's clear it. So Clang. I'm going to be lazy. Boom. Let's run it. Holy smokes, it worked. That's amazing. So think about that. We assigned 5 to a variable called a. We got its address. Then we made a function and passed the address of this variable to this function. Okay, right up here. We added 10 to the value stored at that address and assigned it back on itself. Okay, and then we printed out the value of a. And sure enough, it worked. That's amazing. So there's a ton of stuff. Now, FYI, this isn't how we would normally do this. And we're going to get into that next. And we would solve this problem using what's called a reference. Okay, we're going to get into that next, not this video. But it'll make this look a lot prettier instead of all these star symbols and weird syntax. But this is the meat behind pointers. There's a lot of really neat stuff we can do with pointers, but I want to make sure you understand this. So start playing around with it. Maybe while we're at it, let's do. Let's see. Do I want to do that? Yeah, sure. Why not? Let's make another variable. Int b equals 5. Whoops. Now let's make this 10. Okay. So for now, let's get rid of this function. We don't need it. We're not going to mess with it. Let's do this. Let's make another pointer. Int pointer to b equals the address of b. Okay. So let's get rid of this. So real quick, let's print the addresses of each of these pointers. So cout pointer, let's see, pointer a equals and because I'm lazy, I'm just going to copy this. B. All right, so if I run this, I'm going to print out the addresses of both of these pointers. Okay, so let's do it right now. Let's go Clang. Okay, now you can see here is the address for A, and here is the address for B. Okay, these are ints. You can see they are 4 bytes off because that's how big an int is. Let's play with the addresses some more. Let's take the address of B, okay, the address of B, and assign it to the address of A. So let's go ptr A is going to equal the address of B. Okay, so now if I print this off, I'm going to see the address of A and the address of B are going to be equal. Okay, so what can we do with this? Originally, A was assigned the value 5. Okay? So now if I dereference this pointer, okay, so let me copy this down here. Copy. I'm gonna do it like this. The value stored in pointer A. Now we're going to dereference it. And then let's copy this whole thing. Okay, so I'm going to assign these two. We're going to get the address of both of these, so these should both be the same. And I'm going to dereference both of these, so the variable should be the same. Okay, so let's run this real quick, just see where we're at. So Clang. You'll see the value stored in A was 5, B was 10, and we made the addresses the same. Okay, you can see here's the old address for A right there. Here's B. So now pointer A is now pointed to B and pointer B is still B. And then sure enough, when I dereference both, they're both pointing to B. Now what's really cool is you can start changing their values here. So let's change the value of B. So let's dereference it. B, let's make that equal to 20. Okay? And let's copy this whole mess. Let's just do it again. And let me give myself a little note here. STE, oops. Changed the value stored in B. Let's print this. Okay, so we're just printing all these values off yet again. Okay, let's Clang this guy. Boom. Boom. Now look what's going on. Again, because we assigned the address of A right here to equal the address of B, when I change the value stored in B, I also change the value stored in A. So now A is 20 and B is 20. So play with this a little bit, see if it makes sense to you. If you got questions, let me know.